Hello, you're welcome. All right, now we are going to be looking at a very important topic in mathematics, and that is sword. Okay, so what's a sword? Now, a sword is an irrational number. Okay, or swords are irrational numbers. Swords are irrational numbers expressed in a square root. Okay. Of course, you know what an irrational number is. An irrational number is a number that cannot be expressed in ratio. So any rational number that is expressed in a square root or in a square that is in a square root form are called sword. So example of sword are square root of 2, square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10, etc. Now, let me tell you what makes this number irrational, okay? Every irrational number cannot be expressed in a ratio or a fraction because the value of that of an irrational number is almost like it's a recurring decimal, okay? um More like a recurring decimal. That's what you get as a value of an irrational number. Okay, okay, let me tell you why all these are called sword. Let's take example the square root of, for instance, the square root of 2. Okay, I'm gonna get a calculator now, then I will evaluate the square root of 2 with a calculator. You see what I will have. Okay, square root of 2. As you can see, this is the digit 1.414. These are long digit which I cannot express as a ratio, very long. And this digit you see here is even the approximated value that the calculator was able to round off. Okay, so that is why square root of 2 is a sword. All right, so square root of 3, square root of 5. Now the question is, how do you know a sword? For you to be able to know square root of numbers that are solved, the very first thing you need to know are perfect square. Okay, because if a number is not a perfect square, then it will be a sword. So let's look at perfect squares. Okay, all right, now let's look at them, starting with 2. 2 times 2 is a perfect square. Okay, it's a perfect square because 2 times 2 of course is 2 raised power 2. So that's why we call it a perfect square. And 2 raised power 2 is 4. So it's when I find the square root of 4, I will have a whole number, not a sword. The same go with 3 times 3. 3 times 3 is equal to 9. And of course, when I find the square root of 9, I will have 3. Okay. 4 times 4 is 16. Then the square root of 16 will actually yield 4. 5 times 5 is 25. Then the square root of 25, okay, yields 5. Okay, 6 times 6, 36. Okay, so if I should find the square root of 36, okay, that's gonna be 6. So so you get to know all the perfect square. Can go on and on, okay, as much as you can actually go. That this simply means that apart from this perfect square, any number that is not among this perfect square, 4, 9, 16 are sword. That is why, okay, in my list of swords, the square root of 3, square root of 2, square root of 3, I didn't include square root of 4 because square root of 4 is a perfect square, okay? So the square root of 4 is not a sword. And I didn't even include the square root of 9 before I get to the square root of 10 because square root of 9 is not a sword, okay? So for you to be able to know sword, okay, you get to know the perfect square, and it's good for you to know the perfect square. Why? Because in simplifying a sword, you need to be able to know a perfect square, okay, that is a factor in that particular sword you wish to simplify. We'll get to that uh, in a jiffy. All right, so now let's proceed. Okay, let's proceed. So we are going to be looking at basic sort. What is a basic sort? When is a sort said to be in a basic form? Okay, now basic sort is a sort in its simplest form. Not all swords are in their simplest form. Okay, so a basic sword is a sword in its simplest form. Why? Because that sword does not have a perfect square. It doesn't have a perfect square, no perfect square. Perfect square as a factor. So you can actually reduce that sword or split that sword into two factors in which one of it is a perfect square. So that sword is in its simplest form. So anytime you are being asked to simplify a sword, okay, you are actually simplifying that sword to get a basic sword. Example is the square root of 2, square root of 3, square root of 5, alright, square root of 7, square root of 10. Now, square root of 8 is not a basic sword. Why is square root of 8 not a basic sword? I'll tell you why. Square root of 8 has two factors, okay? I can split it into two factors in which one of it is a perfect square. So 8 is something as 4 times 2. And we know already that 4 is a perfect square, and the square root of 4 gives a whole number. So this is going to be same as square root of 4 times the square root of 2. Okay, so if I find the square root of 4, I'm going to have 2. Then I can't find the square root of 2, okay? Square root of 2 is a sword. So you discover that square root of 8 is not a basic sword. So by simplifying it, I actually simplify it into a basic sword, which of course is 2 root 2. So I hope that is well understood, okay? So take note of that. Now before we actually simplify a sword, we should actually look at the rules, okay? Rules of sword, because every mathematical operation requires, okay, every mathematical operation requires you to obey a particular rule for you to be able to successfully evaluate that mathematical operation. So now we are going to be looking at the rules of sword. Okay, one of the first rule, I can call it multiplication rule, okay, in which if you have a sword, of course, sword square root of a times the square root of b is something as the square root of a multiplied by the square root of b. So you can split multiplication the same way you can also split division. The same way you can split division. So if I have the square root of a all over b, okay, is equivalent to the square root of a divided by the square root of b. Okay, number 3. If I have square root, okay, if I have square roots, that's okay with different coefficient. Let's say c square root of a, and of course d square root of a. The only way I will simplify this is to factorize. Okay, this is something as square root of a. I open a bracket, then I add c plus d. So it simply means that if a square root is of the same, if you have the same square root, okay, having different coefficient, square root can actually be added based on their coefficient or the rational number that is attached to the square root. For example, if you have 2 root 3, then plus 5 root 3, okay, all I just need to do is just to take the root 3 out, then of course add the 2 plus 5, which at the end of the day, 2 plus 5, that's 7. That'll give me 7 root 3. The same thing goes with subtraction, okay? So if you have c the square root of a minus d the square root of a, okay, it's equal to the square root of a, then c minus d. Okay, now these are the do's, but let's look at the don't. The don't is you cannot say that the square root of a plus b is equal to, this is not equal, okay? You don't do this. This is not equal to the square root of a then plus the square root of b. It's not equal. The same with minus sign. You cannot split minus sign, and you cannot split this plus sign in a sword. So this is not equal to the square root of a minus square root of b, okay? Remember, for every rule, there's always a do and a don't. Okay, having known all that, now let's look at some example. All right, so evaluate the following. Okay. A, the square root of 8 plus 2 root 3, 2 root 2, please pardon me, minus the square root of 18. B, the square root of 32 plus the square root of 50 minus the square root of 18. Okay. C, the square root of 27 minus the square root of 12 plus 4 root 3. Solution. Okay, so to evaluate this is actually is the same as simplifying this to the lowest term, right? So now let me start with A. The square root of 18, no, this is not a basic sort, so I can actually, okay, reduce it into a basic sort. 8 has a perfect square as a factor. 8 is the same thing as 4 times 2. Okay, then of course 2 root 2 is a basic sort. I'm not splitting this one. But root 18 is not a basic sort. Root 18 has two factors. One is a perfect square. 18 is 9 times 2. Okay? Of course, according to the rule of sort, I can split multiplication, right? So it's something as square root of 4 times the square root of 2. Alright? Then plus 2 root 2. Then minus the square root of 9 times the square root of 2. Of course, the square root of 4 is 2. It's a perfect square. So that will be 2 root 2 plus 2 root 2. Then the square root of 9, you know that is a perfect square. Square root of 9 is 3, so I have 3 root 2. Of course, now I can simplify this. You know, here I have a common square root, okay? Common square roots. I will take out the square roots, okay, by factorizing. Then of course I will add up. This is going to be 2 plus 2, then of course minus 3. 2 plus 2 is 4. 4 minus 3 is 1. So I have 1 times the square root of 2, which of course is still square root of 2. That is the answer to that. Then B part of the question. the square root of 32. Okay, 32 has two factors. The perfect square is 16. That's going to be 16 times 2. And that's why I say you should know the perfect square. Sorry, know how to multiply. Okay, you multiply by the highest perfect square. Because I would have also gone by multiplying 32 to be equal to, okay, I could have used other factors, but all I need is just two factors in which one of them is a perfect square and the other is a surd. That's what I will always do. Okay, the same thing happened with the square root of 50. Okay, 50 has 25 as a perfect square and 2 as a surd. 18, we know already that that's 9 times 2. Okay, so with what we have now, we can actually split this. This square root of 16 times the square root of 2. Okay, this is going to be square root of 25 times the square root of 2 minus the square root of 9 times the square root of 2. Okay, let's do this. The square root of 16 is 4. So this 4 root 2 plus 5 root 2, then minus 3 root 2. 4 root 2 plus 5 root 2 is 9 root 2. Minus 3 root 2. 9 minus 3 is 6. Okay, so that's 6 root 2. Or we go by what we did before. Just take the root 2 out, open bracket, 4 plus 5, then minus 3 is still going to be the same thing. Okay, 4 plus 5 is 9, 9 minus 3 is 6, so 6 times root 2. So that will be 6 root 2. Alright, and of course, you know very well that I cannot multiply an irrational number, okay, by an irrational number, so I will just attach them. Okay, the 6 is a whole number while the root 2 is a surd. You know that already. So the C part of the question, C, I have the square root of 27, okay, minus the square root of 12, then plus 4 root 3. All right, so what do we do here? 27, how do I split that into? So 27, of course, is 9 times 3. 12, what we have is 4 times 3. Then plus 4 root 3. So this is going to be square root of 9 times the square root of 3 minus the square root of 4 times the square root of 3 plus 4 root 3. Please pardon me. Square root of 9 is 3. So having 3 root 3 minus 2 root 3 then plus 4 root 3. Okay, you can add 3 root 3 plus 3 root 3 minus 2 root 3 is 1 root 3. 1 root 3 plus 4 root 3, that will be 5 root 3. Okay, of course it's still the same method. It's the same thing by taking the root 3 out, then now do 3 minus 2 plus 4, which of course is 5 root 3. Okay, so I hope that is well understood. Please pardon me. Alright, so here we go. Now we are going to be looking at rationalization of surd. So already I told you that a surd is an irrational number. Okay, so rationalization of surd. So the rationalization of surd we are going to be looking at is the one in a surd. Okay, a surd that is that finds itself in the denominator of a fraction. For example, this fraction is not rational. Why? Because the denominator is a surd. Okay, so for me to rationalize, how do I rationalize this kind of a sort of this nature? All right, I have to rationalize this. Of course, rationalize this is just trying to make sure that the denominator, okay, is not a sort, it's a rational number. So to do that, how do I do that? I have to multiply the numerator by that sort, by the sort, and the sort is square root of a. And of course, whatever I do to the numerator, also do to the denominator. So I have to still have to multiply the denominator by the square root of a also. So of course, 1 times square root of a gives me square root of a. And of course, square root of a times square root of a, that will give me square root of a square. Of course, you know that the square root of a perfect square is that perfect square, right? A square. So of course, square cancels square root. So I'm left with square root of a then divided by a. So now the denominator now doesn't have any sort. So it has been rationalized. So let's look at example. So example, simplify the following: a root 3 root 2 all over root 3, b root 5 divided by root 6, okay, c 1 all over 2 root 2, d root 6 divided by 2 root 3. Alright, let's go. Solution. So we have to rationalize, and you know how we do that? We'll multiply the numerator by the sort in the denominator. Okay, the sort in the denominator. So that's root 3. And of course, still multiply the denominator by that same sort. Okay. Of course, root 2 times root 3. Okay. Sorts can multiply themselves, right? So root 2 times root 3 gives me root 6. And of course, root 3 times root 3 gives me root 9. I now know root 9 is a perfect square, right? Root 6 is not a perfect square, so I'll keep it in a sort form. Alright, the square root of 9 is actually 3. Okay, so that is rational sort. 3 now in the denominator. That's rational. Okay, then b. Square root of 5 all over the square root of 6. So this is going to be equal to the square root of 5 times the square root of 6 divided by the square root of 6 times the square root of 6. Square root of 5 times the square root of 6 is the square root of 30. Square root of 6 times the square root of 6 is square root of 36. Okay? And you know 36 is a perfect square. The square root of 36 is actually 6. Alright. Then C part of the question. 1 all over 2 root 2. Gonna be equal to 1 times 2 root 2. Then divided by 2 root 2 times 2 root 2. 1 times 2 root 2 is still 2 root 2. Then of course, 2 root 2 times 2 root 2, of course, 2 times 2 is 4. Remember, you have to multiply rational number to rational number, then sort to sort, right? Square root of 2 times square root of 2 is going to give me square root of 4. So this is going to be equal to 2 root 2 divided by the square root of 4 is 2, alright? Then 2 times 4 is 8. So of course, rational number at the numerator will divide itself to give me 1, divide 8 to give me 4. So what we have is root 2 all over 4. Okay, Then the last but not the least, root 6 minus 2 root 2. Root 6, okay, divided by, please pardon me, divided by 2 root 2, not minus 2 root 3, okay? So I'm having root 6 multiplied by the sod in the denominator. The sod in the denominator is root 3. Okay, so the 2 root 3 I still multiply by the sod root 3. Okay, root 6 times root 3. Root 6 times root 3, of course, gives root 18. Okay, then root 3, 2, root 3 times root 3, okay, is root 9. And of course, the square root of 9 is 3. Let me write this one. So I'm having 3 times 2 is, okay? 3 times 2, which of course is 6. Now, you discover that this numerator here is not a basic sort. Please take note, because in simplification, I'm simplifying to the lowest level, to the lowest, okay, term, and that is a basic sort. So let's work on this. 18 is, of course, is 9 times 2. Of course, all over 6. The square root of 9 is 3. Then I have root 2, then divided by 6. 3 divide itself 1, divide is 2. So my final answer is root 2 all over 2. So I hope that is well understood. Okay, so that is how we evaluate rationalized sort. But there's another form of rationalization, okay? Rationalization by conjugate. Rationalization by conjugate. Now the question is, what is conjugate and when do we apply rationalization by conjugate? When you have a fraction of the form, let's 1 all over root a, then plus root b. Okay, now this is different from what we treated previously. Why? Because the denominator now is having 2 sort that is connected by a plus sign. Okay, that is an operator. Unlike what we had before, there's no operator. Okay, there's no plus or minus sign in the denominator. So how do you rationalize if you are being given such a sort or such a fraction? Okay, so we'll multiply. Okay, so for you to rationalize, you multiply the numerator and the denominator by what? By not the sort in the denominator now, but by the conjugate. By the conjugate. Of what? The denominator. So I'm going to multiply everything by the conjugate of the denominator. Now the question is, what is the conjugate of the denominator? Root a plus root b is first my denominator. The conjugate of that, okay, is going to be equal to root a minus root b. So conjugate of any binomial expression is still that expression, okay, but you change the sign. If it was plus, it will be minus. If it was minus, it will be plus. Okay, so now let's do this. So that simply means that I have to multiply 1 by the conjugate of the denominator. What's the conjugate of this denominator? That's root a minus root b. So I put that in a bracket. Root a minus root b. Then whatever I do to the numerator, I also do to the denominator. So the denominator too, where I have root a plus root b, I'll still multiply it by its conjugate, which of course is root a minus root b. Okay. 1 times root a minus root b is still going to give me root a minus root b. So of course I know very well that at this point you want to expand. Okay, you want to expand this. But that's what is this bracket here, these two brackets, we call the difference of two square. The same expression is found in the two brackets, but the only difference is that one is plus, the other one is minus. So this is what is called difference of two square mathematics. Of course, you know, it's like this: x plus y times x minus y. The difference of two square. To evaluate it, to expand it, simply take x and square it minus y square. The first element square minus the second element square, right? That's exactly how I will simplify this. So that's gonna be the square root of a square minus the square root of b square. Of course, you know square cancel square root, okay? Of course, so we have this root a minus root b divided by a. Square root of a square is a, okay? Then minus b. So now let's go by example. Evaluate the following. A 2 all over 1 plus root 2. B root 2 divided by root 3 minus root 2. C root 3 plus root 2 minus root 3 minus root 2. Okay, all of them are fraction division. Solution. Let's start with this. 2 all over 1 plus root 2. You know what I would do? I'll multiply by the conjugate of the denominator. What's the conjugate of 1 plus root 2? The conjugate of 1 plus root 2 is 1 minus root 2. Divide bracket. 1 plus root 2. I still need to multiply by the conjugate, which is 1 minus root 2. Okay, let's do this. So I have to expand this. 2 multiplied by 1 will give me 2. And of course, 2 multiplied by minus root 2, that's going to be minus 2 root 2. Then divided by difference of 2 square. Remember, the denominator is difference of 2 square. That will be 1 square minus root 2 square. Okay, of course. This is going to be 2 minus 2 root 2. Okay? Then divided by 1 square is 1. 2 square is 4. The square root of 4 is 2. So I'm having 1 minus. So I'm having 2 minus, okay, 2 root 2 divided by 1 minus 2 is minus 1. So I'm dividing everything now. and dividing the entire numerator by minus 1. If I divide 2 by minus 1, I have minus 2. Then, of course, if I divide minus 2 root 2 by minus 1, I'm going to have plus 2 root 2. So that is the answer to that. Okay. So, I hope you are following me. Okay, I have to solve the B part of the question. Okay, so here we go. So, of course, I have to also rationalize by conjugate. What's the conjugate of the denominator? That is root 3 plus root 2. So I'm going to have root 2 multiplied by the conjugate, which is root 3 plus root 2. I'll close my brackets. Then, of course, I still need to multiply root 3 plus root 2. Please, root 3 by minus root 3 minus root 2. By that same conjugate, which of course is root 3 plus root 2. Okay, let's look at this. So expanding, root 3 times root 2, that's going to give me root 6. Root 2 times root 2, that gives me root 4. Divided by difference of 2 square, don't forget. That's square root of 3 square minus the square root of 2 square. Okay, so it's going to be square root of 6. The square root of 4 is 2. Okay, 3 square is 9. The square root of 9 is 3. I have 3 here. Okay, of course, this square root of 4, which is 2. So 3 minus 2, that's 1. 1 divided by root 6 plus 2 will still give me root 6 plus 2. Okay, then the last but not the least. Okay, root 3 plus root 2. Then, of course, divided by root 3 minus root 2. The denominator, the conjugate of the denominator is root 3 plus root 2. So I'm going to multiply root 3 plus root 2. And of course, since there are 2 of it, okay, it's going to multiply the conjugate, which is also 2. I have to put them in a bracket. Okay, the conjugate of the denominator is still root 3 plus root 2. Okay, then I'll do the same to the denominator. Here I have root 3 minus root 2 multiplied by the conjugate, which is root 3 plus root 2. Okay, so let's go. Let's evaluate. Okay, so in this case, for the numerator, I am expanding. Okay, I am not going to, it's not difference of 2 square. So in our shortcut of expanding, you know how we do that. Okay, let me apply the shortcut of course, you take the very first parameter there, square it, that's root 3 square. Okay, of course, this is a perfect square. The whole of this is a perfect square. This is something as root 3 plus root 2 all square. So I will work it, I will actually evaluate the same way I evaluate a square. Okay, now I use 2 times root 3. So what I now have is 2 multiplied by root 3 times root 2. Root 3 times root 2, that's going to give me root 6. They are now square the root 2 square. Okay. Now, don't forget denominator is difference of 2 square. Root 3 square minus root 2 square. Okay, so let's do this. Of course, square cancel square root there. Or 3 square is 9, the square root of 9 is 3, okay? Then plus 2 root 6. Of course, plus 2. Square root of 4 is 2, okay? Divided by, you know what happened? Square root of 9 is 3. Square root of 4 is square root of 4 is 2. 3 minus 2 is 1. Okay, so adding up, collecting items, root 3 plus root 2, that gives me root. Please, 3 plus 2 is 5, not root 3, okay? Then of plus 2 root 6. So if I divide it by 1, I'll still have that. So my answer is 5 plus 2 root 6, okay? So that is how to evaluate sort based on conjugate, all right? So we might be looking at some other questions in the next video, okay? See you in the next video. Thank you.